Hi everyone and welcome back to Maths and Physics with Mr. Simons, where we make maths and physics simple and we get you exam ready. Alright, today's lesson I'm looking at grade 11, mainly exponents, not really sets. Right, and we're looking at the basic variations of exponents questions that are tested in grade 12, or what I simply refer to as general exponents exam questions. Right, they are surprise exam questions, but that would be in a totally different video. Alright, so I'm going to start off. I give you a breakdown of everything you should have learned and know from exponents and surds. Right, so exponents and surds, we have our types of questions. So first question, basically in all exponential questions, we're going to test the laws of exponents and its rules. So when they say laws of exponents, what do we do when we multiply and the bases are the same? We divide and the bases are the same. Rules, how do we deal with negative exponents or anything to the power 0, etc. Right? Now, under exponents, we can test common factor problems when we're adding or subtracting and the bases are the same. They're normally separated by a plus or minus sign. Then we can test multiplication and division of exponents. Right? And we test whether you can simplify that expression. And normally, most of the time, we're going to start off by making the values given to you as products of its prime factors, meaning we're going to use prime numbers and write it in exponential form. Alright, so those are the basic 4 exponential problems, but you'll see how this 4 can become 5 different problems. Then we have laws of surds. Alright, you should know how to add and subtract surds by making them like terms. Add and subtract surds, where you're first going to test your distributive law. Can you find the products? And then add the like terms. Right, we're going to test difference of two squares and the first law of surds. So we're going to multiply basically your radical sign with another radical sign. We're going to test squaring surds and simplifying. Simplifying surds involving fractions. Solving equations involving rational exponents. Simultaneous exponential equations. So there's simultaneous equations, but that would be under equations. Simplifying equations with rational exponents by means of factorization. And factorization involving, okay, that too is actually the same thing. Right, but I hope you get the idea. You can pause here, write it down so that you can check what you know and don't know. If you want to, I can do you a lesson on each item, specify them. Right, so problem number 1, solve for x. It gave me x to the power 1 over 3 equal 4. So to solve for x means I need to get x to the power 1. So to make 1 over 3 1, we normally multiply by its reciprocal. Right, so 1 over 3 times 3 over 1 would become 1. So there, in brackets, I raise it further to the power 3. What I do one side, I have to do on the other side. So if I raise there 3, 1 over 3 times 3 gives me x to the power 1, 4 to the power 3, which is 4 times 4 times 4, gives me 64. So 1 there for raising to the reciprocal 3, and then 1 for the answer. 1.1.3, also these questions are all from past exam papers. No? So now we have 2x negative 5 over 3 equals 64. So the difference is here. I've included an extra value. So first we're going to say 64 divided by 2 to get to 32. We want to solve for x, so we always want x on its own. So 64 divided by 2 then gives me 32. Alright, to make that 1, remember as I said, we're going to multiply by the reciprocal, which means if that's negative 5 over 3, I have to multiply by 3 over negative 5 to make it 1. Right, so what I do on one side, I must do the other side. 32 can be expressed as 2 to the power 5, meaning 2 times 2 times 2 times 2 times 2 would give me 32. Right, and I'm raising it to the same, 3 to the negative 5. Right, so there 3 and 3 cancels, negative 5 and negative 5 cancels, and I'm left with x to the power 1. 5 and 5 cancels. Right, so I still have a negative, so that becomes negative 3. To make a negative exponent positive, we take it to the bottom of the division. So it becomes 1 over 2 to the power 3. And I assume we know 2 to the power 3 then becomes 8. So negative exponent goes to the bottom to become positive, and 2 to the power 3 is 8. So 1 mark for dividing by 2. Another mark for raising to the correct exponent, 3 over negative 5. 1 mark for simplification, and 1 mark for the final answer. Right, let's go look at the next problems. So for x, they gave me 3 to the power x times 3 to the power x plus 1 equal 27 to the power x for 4 marks. So because we have multiplication there, we're first going to try to make all the bases the same. First law states if the bases are the same, you see there 3 and 3, then I add my exponents, so that becomes x plus 1. 27 can be expressed as 3 to the power 3, meaning 3 times 3 times 3 would give me 27. X. Alright? X plus x gives me 2x plus 1. Third law of exponents, 3 times x becomes simply 3x. Right? Now, because my bases are the same, I can drop the base 3 and I solve using the exponents. So I have 2x plus 1 equal 3x. Right, if I take 2x across, 3x minus 2x would give me x equal to 1. So 1 mark there for 27 becoming 3 to the power 3 and adding the exponents. Another mark there for simplification. 1 mark for dropping the bases and 1 for the final answer. 1.1.4. If you look, they look very much the same. The only difference is there was a multiplication sign and here's a negative sign. So I have 3 to the power x plus 3 minus 3 to the power x plus 2 equal 486. So whenever terms are separated by a minus or plus sign, we'll always look for a common factor. Right? But yeah, my first split, so that's 3 to the power x times 3 to the power 3 minus 3 to the power x times 3 to the power 2. That way there, now you can see on either side of the minus sign, I have 3 to the power x, which is common. So if I take out 3 to the power x, now I'm left with 3 to the power 3 minus 3 to the power 2. So 27 minus 9 gives me 18. Right, and then from there, to get rid of multiplication, remember this is now 3 to the power x times 18. I'm going to divide. 486 divided by 18 would give me 27. 27 is 3 to the power 3, so now again my bases are the same. Therefore I can drop them and I'm left with x equal to 3. So 1 mark there for splitting my exponents, or expansion as they say sometimes. Taking out the common factor, simplification through division, and final answer. Alright, look at the next slide. So yeah, we're simplifying. Again, no equal to, so we have expression. We have 3 to the power 2015 plus 3 to the power 2013 divided by 9 to the power 1006. On top stays, bottom I have to make base 3. Alright, so 9 is 3 to the power 2, 1006. Right, second law of exponent, or third law of exponents, 2 times 1006 would give me 2012. Right, so on the top there, as I said, whenever terms are separated by plus or minus sign, we'll always look for a common factor. Now technically I can take out 2013, but we haven't tested a true common factor for a while. So I'm going to take out the exponent that will cancel with the bottom. So on the top I take out 3 to the power 2012, 2015 minus 2012 gives me 3 to the power 3 plus 2013 minus 2012 gives me 3 to the power 1. Now the two factors can cancel there, and I'm left with 3 to the power 3, which is 27 plus 3. That gives me 30. Alright, so the common factor concept. Right, let's look at the last problem. So 1.2.3, now we have the common problem where we're dealing with multiplication. First step, 25 not a prime number, 15 not a prime number, so I'm going to find prime bases. So 25 can be expressed as 5 to the power 2, 15 with prime basis would be 3 times 5. All right. So 1 mark for prime basis. Second mark for correctly multiplying. So 2 times negative x gives me negative 2x. Then remember, everything in the bracket must be multiplied with everything outside the bracket. So that would be 1 times x plus 1 gives me 3x plus 1. That would be 5. 1 times x plus 1 stays x plus 1. The bottom I have 3x and 5 negative x. Right now, my bases that are the same, I have 3x plus 1 and I have 3 to the power x. Everything on top, the exponents stay as they appear. But if I come below the division line, remember second law says I subtract exponents. So by subtracting exponents, we simply changing the sign of the exponents at the bottom. So base 3, x plus 1 stays the same. Come below the division line, positive x becomes negative x, because we're subtracting exponents. Base 5 on the top, everything stays the same, so that is negative 2x plus x plus 1. If I come below the, if I come below the division line, sorry, the English just left me. If I come below the division line, minus x times the negative would then become positive x. X minus x cancels, and I'm left with 3 to the power 1. Minus 2x plus x cancels, and I'm left with 5 to the power 1. 3 times 5 would then give me 15. And as you can see, my mark allocation, as I said, prime factors, correct multiplication, correct use of law 1 and 2, and then fourth mark for final answer. So these are just some general exponential questions. Work through it, get to know it. If you're practicing the others, you should know the process. Right, in the next video, I'm going to do you the surprise exam questions, right? God bless, love you, bye.